Okay, so where was I? I'm having the goal of oh, that's already here. I'm having the goal of in part 5 here that the goal of this script will be to ensure and verify that the initial parts of the forward pass up to the beginning of the first transform block will match Hugging Face Qwen3. And we are at a point where we can load the Qwen Hugging Face model and get the hidden states for the residual stream before we enter block 0. And that's good. And then we are now trying to do the same here. And say this is belonging here. So what we're doing here is we are saying let's import everything from part 4, preliminary quemma forward pass. Can you do something like that? No. Import from plot import. So we are for some reason there's something about tokenization that is very slow. No, it's not tokenization now. Adding W's. Adding W's. What does this mean? Adding W's. It's in here. Okay. Now we at least have it. So this is the output, and I think now I enabled this thing called capture intermediates. So I would be interested in knowing what is going on here. If there is some tree scope, the out quemma. So I have the output logits, and then I have some intermediates. Output, is it like this? No? Output. Intermediates. 0. And 1. Okay, here we go. And you're capturing it in all of them. And it's all the intermediates. That's awesome. This is really awesome. So I was thinking this thing, right? This is the 4 tokens. And then we just have to figure out its this is the output or the input that it puts in this call one. I would assume, yeah, we can see here the call to the whole thing is this. And then you have so let's look at this one. Out Qwen3 intermediates layer 0, layer 0, call, what is that? 1. Okay. 0, 1. This is a nice thing because it has a shape 14102. And up here I am doing 2 of these, and I say Qwen HF So already now there's a difference, of course, in the size. So hi there, how are versus hi there, how are. So I might need to fix this later. Okay. So this is Qwen3 R S0, where R I mean residual stream and S0 I mean at depth 0 before the first block. So now I have Qwen3 R0. This is still not a matrix apparently. It is like that. Great. And then I'll just turn this into so I'll just turn it into Jax up here. So Jax.dlpack from dlpack. I don't know if this is a good way to do it, but it so yeah, I just turned it into this now. And we have 2 arrays, and they're clearly not the same. They're clearly not the same. So that's all fair. also not S1, right? No. Okay. So the Qwen ones are quite small. They might have been somehow normalized, while these have not. So, let's try to get into the code base now. This is now in the transformers library. We don't care about that one. Jax is not defined. Yeah, this is where I was last time. Inside the apply, there's some kind of thing. I'm gonna go into these and see, just to understand a bit. What happened? It's making the forward pass now, I think. So I missed it. I'll try again. Here. No, not this one. The 5. This one. Bam. I could also just see if I can find it. It is called transformer, and it has some stuff here at least. And I just want to transformer. somehow get some kind of modules. That was what it was called. Modules. Module. No. What was it called then? Modules of pi. What? Let's just go in here. Maybe the debugger doesn't work. There's something with checks, right? But is it only if you compile, or will you always have problems? Looks like you will always have problems. Modules. What happens if I say like this and block I wish I could just kind of open it here. Gamma. Flex. reveal it. Okay. Then we are now here, and I go. Okay, so at least see this, and we can do something like this. And we could also yeah, so change the debug, the print. this. Before normalize. Maybe like that. Well, that did not work. X000. And that is now him inside a block. But there's no jacks.debug.print. Jacks.debug.print. Oh, here we go. I was just stupid. Okay. Yes, it works. Okay, let's see here. Before normalize, it says this. 0.291748. That's very good because it's the same as this 129 1748, and then I normalize it. And usually we do not normalize it. We do not normalize it in Qwen. Qwen does not normalize it, so what do? We would like that, I'll just write it down so I don't forget. Rescales the embeddings in modulus.pi. We do this, and that's fair enough, but it's not what we want. We want that it's not normalized or rescaled. And what could we do? We could either add a line that says if blah blah blah, but then we will have to maintain that. But it's also fair enough, I think, because it would be worse to just try to work back and have some kind of embeddings that are robust to the rescaling. I wouldn't want that. So I don't think we have any choice but to modify the code base, and we will anyway have to do it. So let's see here. This is the general idea. If self blah blah blah. So if we then look at part 4, like this, will I have access to it in here? Will I have access to this variable? Or do I need to do something smart in order to get access to it? So can I just go in here and say can I just go in here and say Qwen3 setting, what was it that I did? Qwen3 setting rescale embeddings. Bool false. Bool true. True. Normally it's true. And I now have the problem that I'm modifying a code base that I want to ensure works well with the existing gamma. So I should maybe be branching, but I'll wait with that. Qwen3 setting rescale embeddings. Then you say that on line 100 No, this is the wrong line. This is the wrong line. Attention. Block. Block. Yeah. I'm more like here. Transformer. Something like this. Okay. Where? There. Here you are, I'm inside an embedding. Okay, what does it say? It says false. That's very good, because now I can then do if self dot self.qwen equals false. Then I will do this. So So now I will just have to think about something more, because we saw that the captured value was not the result of the embedder. That was the thing. The captured result was not the so this is in some sense not the residual stream. This thing here. Let's try to run this. So we're saying layer 0, there's all this stuff, but actually this is not what we're about. We're about something that's not even here. We have to go and see whether we can understand this matrix, where it is coming from. If it is the matrix that we have or some other one. It starts with minus 2.29. And it is not the embeddings, it's something else. So we agree that we have the same thing here, and then the encode going to, let's see. Block. Embedder. And in here, yeah, we're just gonna go directly forward to layer 0 and say, what is going on in here? It's a block. It's a block. It's a block. It has a call method. Hey yo, I'm inside a block. Jax.debug.print line print inside block. The x 0, 0, 0 is like that. And we would hope that it's minus 0.2. Minus 0.02. Whoa. It didn't like that. I didn't see it take this long before. Okay. And it says, actually, we are still embedding it. Hey, I'm inside the embedding. False. Embedder. If is true, then we do it. But the other thing we know is that we are now right. So it is not this thing. This is probably the return from the call to layer 0, and maybe this will be the additive residual, probably. So we have some block. Some block there, and we called it, and we probably use okay. At least we now have that inside some block, and inside that block we have that value, which is a good value. And then then we have to see what happens, because there is some kind of normalization before the attention. Pre-attention normalization. That call returns a vector of normalized values. And that's the next step. But actually we completed with the goal. The goal was to ensure that the residual stream is the same beginning on the first transformer block, and we completed that. So I will just take a break, and then that will be the next step. So step 6, part 6, will be to do the pre-attention step 4, pre-attention normalization should agree. Okay.